Hello everyone, I welcome all of you to the second session on data representation. So guys, what is that we have understood and we have discussed in the previous session? I was discussing about, let me get into the next slide, that is recap. In that, let me discuss in detail. So guys, I have discussed what exactly the number system is all about. So I hope all of you would have gone through the video. So we have discussed what exactly the number system is all about. In this number system, how many different types of number system we have? So in that, please understand, we have discussed mainly that is binary number system, decimal number system, octal and hexadecimal. So we have come to know that we have 4 different number system. So how exactly it is represented is what we have discussed in the previous session. All right. So what is that we have in this session? So that's a question mark that all of us have. Yes, we will be understanding the very important concept, how exactly we will be performing the conversion from one number system to another number system. In the previous session, I have discussed how many number of conversions will happen between 4 different number systems. In this session, I will be taking up an example to show you how exactly the conversion is happening from one number system to another number system. So I want all of you to have a notepad next to you and have a pen next to you. So I will be taking up a problem and then I will show you the method. So which is the method that we are going to implement to perform the conversion. So all set to go. So let's understand some of the conversions in today's session. So what is that I will be discussing? So we have different conversions I have listed out here. The first one is I will discuss the binary to decimal. So how exactly we are converting the binary number to decimal number. That is the first one. And the second one is decimal to octal. I have the decimal number. How do I convert the decimal number to octal number is the second one. And the next one is octal to decimal, octal to binary, and binary to octal, decimal to hexadecimal, and then hexadecimal to decimal. The last one is binary to hexadecimal. So I have these many conversions in today's session. So hope all of you have a lot of energy right now. So guys, let's start with the first conversion. So I have given a diagram here for all of you just to understand the quick conversions, how many different conversions are possible with the help of 4 number system. So basically I have a decimal number system, octal I have, binary and hexadecimal. So guys, all of us know I can convert from binary to binary. Is it binary? No, it's decimal. Please listen to me, have a little concentration. All right, so I have the decimal number system. So can I convert decimal to decimal? Yes, you can convert decimal to decimal. So in the same way, decimal to octal. So octal and decimal to hexadecimal, yes, I can do. And decimal to binary, yes, I can do. So I have 4 different conversions. So in total, 4 number systems are there. So 4 into 4, total I will have 16 conversions is what you need to remember. So let's understand one by one what is the first conversion that I have in this session. The first conversion that I have is binary to decimal. I have binary to decimal. So when I have binary number, how do I convert that into decimal number is a challenge for me. So let's understand. Only the thing is you just have to make a note of the method that I am implementing. So rest everything is very simple. I've taken the simple problems so that you just have to make a note of what is the method that I'm implementing for this particular conversion. So then only it will be easy for you. All right. So that's what you need to do now. So guys, I have binary to decimal. So first of all, I should look at the question. Binary in the sense what? So I should have my question in the combination of zeros and ones. It should be a combination of zeros and ones. My dear students, that's very important. Right? So I have the number in the form of zeros and ones, but please make sure I should have the base as 2. All right? So I have the base as 2. All right? I have the number and the base of this number is 2. So fine, I need to convert this binary number to decimal number. What exactly decimal number? So the decimal number is like, base of this number should be 10. And it can be combination, can be a combination of 0 to 9, any number. So that's what I want. How do I convert that? So that's a challenge for us. All right. So I will be implementing this method. So first, what is that I'll be doing? I have this number. So please understand. So I will start from here. What is the number I have? I have 1. So first I will write 1. That's what I've written here. 1 into. So I'll be starting it from. So LSB, please understand that. So least significant bit. Okay. So please understand. So I'll be starting it from here. So what is the first number that I have? So I have 1. So 1 into 2 to the power of 0. 2 to the power of 0. So why 2 to the power of 0? Why not any other number? Because I am dealing with binary numbers. I am dealing with binary numbers is what you have to remember. So whenever you are converting a binary number so to decimal number, you have to use this 2 to the power of any numbers. All right. So how exactly we are performing this? That's what we are going to look here. Please understand. So what is the first number that I have? I have 1. So 1 into 2 to the power of 0. That's what you have to write. All right. 2 to the power of 0 is 1. So 1 into 1 is 1. So I have written that. So what is the next number that I have here? The second number. Please understand. The second number, I have 1. I will write 1. So I have already written 2 to the power of 0. What is the next number that I have in the power? So it should be 2 to the power of 1. So 2 to the power of 1 in the sense what? It's 2. So 1 into 2, it's 2. I have written that. Alright. So then what is the next number that I have? 0. Alright. So I will write 0. 0 into, what is the next number after this? 2 to the power of 1 I have already. So after this 2 to the power of 1, obviously it is 2 to the power of 2. So but I'll not calculate that because 0 into anything is 0. Directly I will write 0. Right? So then after that, what is the next number I have here? I have 1. Okay? So I'll write 1. 1 into, what is the next number of this one? 2 to the power of 3. So 2 to the power of 3 in the sense 8. So 1 into 8 is 8. That's what I'm going to write. Then after that, next number 0 into 2 to the power of 4. So fine, 0 into anything is 0. So I'll not write anything. It's 0. And then last number that I have is 1 into 2 to the power of 5. You all know that. So 2 to the power of 5 is 32. So I'll write 32. So fine. Now I want the decimal number. So what is that I have to do? I should perform the addition of all this number. So whatever the number that I have, so I'll perform the addition. So my answer will be 43. But I should never miss. I should never forget to write the base as 10 because this is in the form of decimal. This is in the form of decimal. So what is the base of decimal? So it should be 10. So this is a correct answer. Only if you write this base, then only the answer will be complete. Otherwise, you will get only half mark for this question. All right. Please never forget to write the base. It's very important. This is how you will perform the calculation or you will convert the number from binary to decimal. So please take one more problem from my side. So 10111 to the base 2. All right. Please convert this into decimal. All right. So imagine this is a question and this is a base 10. All right. This is the question that I'm giving it to you. Once you are done with this explanation, please pause the video and solve this question. All right. So that's what I want all of you to do it. Not only you will be perfect with the method and make sure that, so you don't write all the problems. You just write method name. What is the method that you have binary to decimal? Write down what is the method that I'm using. That's it. So it is very easy. I don't have to explain to all of you. You guys are more genius. All right. You just write the method, then easily you can recollect and you can perform this calculation. That's a shortcut that you can make it for yourself. By saying this, moving on to the next one, I have decimal to binary. So we had a conversion that, in the previous slide, binary to decimal, but it's a reverse way. So how do we do that? We have the division method. So we will be taking this division method. So to convert the decimal to binary. So first of all, you need to understand what should I want? What should be my result? So that is what you need to remember. My result should be in the form of zeros and ones. Then how do I do this? Obviously, it's very easy to remember that only if I perform the division, I will be able to get zeros and ones. Okay, so as a reminder, so that I will be able to do it. Yes, of course, you can also do this with other methods also, but this is very simple and easy to remember. That's why I have chosen this. All right, that's the only intention. Sir, if you ask me, sir, can I use any other method to perform this conversions? Not only this, any other conversions? Yes, of course, there are multiple methods, but I have chosen the simplest method to explain you guys, so that now it is very easy for you guys to remember. Saying this, let's get into the problem. So what is that I have? I have 125 to the base 10. So can I call this as a decimal number? Of course, you can call this as a decimal number. All right. So is it satisfying all the rules of decimal number? Yes, because it is having a, it's having the numbers like, which is in the range of 0 to 9. But is that only the condition? No, I should also have the base as 10. Do I have that? Yes, you have that also. So I have the base as 10, right? So then after that, so the question is, please understand, they will not give you this sometimes. They'll just give you this question. You need to understand, I should convert decimal to binary. How? Because please understand, so the base is 2. You need to calculate. You need to understand what is the number that you need to calculate. That's what a very important thing that you need to understand. All right, by saying this, we are going for the conversion now. So it's very easy. All of you know that. So I have 125. I will be dividing that with 2. I will be dividing that with 2. So why 2? So because I need to get binary numbers. I need to get the binary numbers. I need to perform the division. So in the previous method, so I was converting from binary to decimal. So what I did the multiplication. I did multiplication with 2 to the power of values. But here decimal to binary. What is that I'm doing? I'm doing division with 2. So this is multiplication and this is division. That's what you need to remember. Only this much you need to remember. Rest everything you can do it. It's very simple. All right. So fine. So I don't have to tell you all these things. So we are doing this from now many years. We are expert in this, but still I've taken it. Let me explain this. So guys, you have 125. So divide that. So you will have 62 and you will have 1 as a reminder. All right. You have 1 as a reminder. Again, you have 62, right? So if you divide that, so you will have 31 and there is 0 as a reminder. So you will keep on dividing. Let me explain this, though you might feel it very simple and easy. Some of the students might not understand. So for them, I'm explaining. So please have some patience if you know this, right? So please listen to me. Those who don't know this method, let me explain it from the scratch. Guys, just look at the problem what I have. I have 125. I need to perform the division now. So with the help of 2. With the help of 2. So what I will do, I have taken 2. Suppose if I perform the division, so let's do the reverse method. So 2 into 62. What will be the answer? Please tell me. So if you perform this, so you will get 124. So you'll get 124. So how many number you have as a reminder? So I have 1 as a reminder. So fine. Can I perform 63? Imagine 2 into 63. So what will happen? 126. So but it is more than that. So I'm taking 124. So I will be writing 62. So what is the reminder? 1. So I have written 1. So I need to divide this number 62. So how do I divide with the help of 2? I have 31. I've taken it already. I'm just showing you. So if you perform 2 into 31, so you will get 62. So I have, so it's completely dividing. So remainder is 0. I'm writing 31. Again, I have 31. I have to divide it. So how do I do it? 2 into, I have 15. I've written 15. So it will give me 30. All right. Suppose if I take 16, so it will be 32. It's more than that. So I should not take that. So I'm restricting it myself for 15. So I'm writing 15. The remainder is 1. So again, I have 15. So I should divide it. So how do I do that? 2 sevens are 14. So I'm writing 7. So 1 reminder. Again, I have 7, right? I should divide it. So 2 threes are 6. So 7, I have 1 reminder. So 3 I have. 2 ones are 2 and 1 reminder. So this, I will bring it here and I will write 0 here. So this is how I will calculate. But this is very simple. All of you will do it, but you will make a mistake here. So you will get a confusion in this step. What is that I'm going to tell you now. So how should I write, sir? From this side or from this side? How should I write? So please understand, that's why I've given the arrow mark. So you should start writing like this. Okay. So whatever you have here, this bit should start from here, or so you can start writing like this. Okay. So please understand this. So this is very important. This is very, very important. Most of you will do the mistake here. So please understand this. You will write it in a different order. You'll write it in an opposite order. So most of you will do the mistake here. Please have a little care. Okay. You will get a confusion when you are solving. So please remember this. It's very important. And don't forget to write the base as 2. This is how you will perform the conversion from decimal to binary. All right. So I will give you one more number. Please take down it as a problem. So please solve 425 to the base 10. Okay. So you have to calculate this for me. All right. This is the problem that I would like to give all of you. So this is the second conversion that we have. Moving on to the next conversion. So I have decimal to octal. What is the next conversion that we have? Decimal to octals. First I should check. So do I have the decimal number? Yes, I have the decimal number. So which conversion I have to perform now? They have not given this. So I have to identify here only. How do I do that? So I should check what is the base that they have given. 8 is the base that they have given. So I should convert the given decimal number. How do you know that this is a decimal number? Because the base is 10. So that's how I got to know that this is a decimal number. From this decimal number, I need to convert it into octal. And how do I do that? That's the conversion that we have. So guys, it's very simple. So there, please observe here, I was using 2. So here, I will be using 8 because you all know, please understand, you all know octal in the sense 8. Octal in the sense 8. The rest, everything, whatever I'm performing the method, it's same. It's same. What is the decimal to octal? So do I have decimal number? Yes, I have. So how do I convert decimal to octal? So I have to divide it by 8. So please understand, decimal to binary. Remember the method. Decimal to binary divided by 2. So remember the method. Decimal to octal. It is 8. That's what the shortcut that you should remember. If you remember that, it's simple. You don't have to worry much. So you will be dividing that with the 8. Again, this is the arrow mark that you should remember. Okay. You will divide and reminders, you will start writing it from this side. So you will write the base as 8. You write the base as 8. It's very simple. That's what you need to remember. Sir, how? Some of you will ask me, sir, how did you got this? Yes, let's try and solve this. So I have this number 1, 2, 3, 4. Suppose if I divide it from 8, so I will be getting 8 into 154 if I write this. So what is that I will get? So I will get 1, 2. I will get 1, 2, 3, 2. Okay, I'll get 1, 2, 3, 2. So remainder is 2. Remainder is 2. So that's why I'm writing 154. In the same way, guys, so how did I got this 154? You understood. Now let's divide that again. So please perform. So 8 into 19. So how much I will get? I will get 152. I will get 152, 2 as a reminder here. In the same way, I will be performing for 19. So how do I get 19? So 8 into 2. So understand, I will get 16. So what should be the remainder? 3. So 8 twos are 16. 3 is the remainder. This 2 I'll bring it down. So this is how I got this number. So for those who don't know how to divide, all right. So all of you know this, but not to skip this because some of the students will not be knowing. So have some little patience. That's why I'm discussing the basic things. All of you are genius in the maths. I know that, but still some of the students, they might get the benefit of this. Is our intention. All right. Moving on to the next one. I have octal to decimal. Octal to decimal. How do I do this? What is the method that I have to implement? So please understand, it's very important and it's very easy. So what did we do in the previous method? Please understand this. Binary to decimal. What is that? Binary to decimal. I'm converting it to decimal. Which number? Binary. So please understand this method. Please understand this method. Remember this method. So what is that I'm using? I'm using the base, but I'm converting it to the decimal. So please, what is the number, from which number you are converting? You are converting from the binary. So that's why you have taken the 2. So remember this method. So I have the next one, I'm converting it to the decimal. So you know multiplication is a method, right? So from which number you are performing? From octal you are performing. Octal in the sense to which number I should take, or which number I should take. So I should take 8. That's the logic that you should remember, dear students. If you remember this, then rest everything is easy. Sir, you don't have to explain, sir, we will do it. That's what you will tell me. So that's why I've taken this method. If you follow the textbook method, it's quite difficult, and so it's very complex to understand sometimes. But follow this. This is very simple and easy steps. Alright, I have 724. So first of all, I should understand, I should check whether it is a valid octal number or not, because so it should be in the range 0 to 7. So do I have any number which is not in the range? Yes. Let me check. So 7 is in the range. 2 I have. 2 is in the range. 4 I have. So 4 is in the range. So can I call this as an octal number? Yes, you can call this as an octal number. Then I need to convert this octal number into decimal. So how do I do that? So first I have to take this number. So even in the binary also we started from the right side, right? So I have taken the 4 into 8 to the power of 0. So always you should start from 8 to the power of 0. Please remember that. So 8 to the power of 0 in the sense it's 1. So 4 into 1 is 4. Again I have the next number is 2. So 2 into 8 to the power of, what is the next one? 8 to the power of 1. So 8 to the power of 1. 2 into 8 to the power of 1 in the sense it's 8. 2 8s are 16. So what is the next one I have? I have 7. 8 to the power of 2 is what? So please understand, 8 to the power of 2 is what? So 8 8s are 64. Right? So 7 into 64 will be 448. Then I will perform the addition. Then it's very important that you should never forget to write the base as 10. This is very, very important that you should remember. Alright. So this is how octal to decimal. So hope all of you are finding it very easy now. So after performing 2-3 methods, now you know the basics. You will just solve the problem very quickly and you will go, right? So even in the coming methods, you will find it very, very simple, very, very easy. You'll just see the methods. That's it. You don't have to worry again. All right. So moving on to the next one, I have octal to binary. What is that I have? Octal to binary. It's very interesting. Let's understand this. I have the number 705. What is the number I have? I have 705. That's what you need to remember. 705. So what is the base of this number? So please understand, base of this number is 8. So I will conclude that this is a octal number. How do I convert this into binary? So binary in the sense what I should have in the combination of zeros and ones. How do I do that? I have a code. Remember this code. I'm giving you the cheat code for you. It's a very easy and shortcut that I'm giving it to you. So I have 4 to 1. What is that I have? I have 4 to 1. Using this code, convert all this number, you will get the binary number. So how do I do that? Let's start. So let me divide this individually. How do I represent this 5 using this code? I have, what is the number I have? I have 5. So please understand. So to get 5, I will be multiplying with 0 or 1. Okay. How do I do that? So I will make this as 1. I will make this as 0. I will make this as 1. This is the conversion of 5 using this code. How do I do that? So please understand. So 1 into 1, it is 1. I will write 1. Okay. So 0 into anything is 0 plus 1 into 4, 4. So 4 plus 1, 5. So that's how I got 5. So what is the code? I will write 101. What is the next one I have? So 0. So I should represent it with 3 digits only. So even if it is a 0, I should write 3 zeros. That's important. You should not miss that, right? What is the next one I have? I have 7. So how do I write 7? How do I convert 7? So using 4 to 1 code. So I'll write 4 to 1. So 1, 1, 1. Okay. 1 into 1, 1. 1 into 2, 2. Okay. Plus 2. 4 into 1. So please write 4. So 4 plus 2 plus 1 is 7. So I will write 1, 1, 1. So guys, so this is your binary. This is what you have got. Okay, this is what you have got. So this is how we convert the octal to binary. It's a very simple method. It's a shortcut to remember. Alright. So this is what you need to remember. In the examination, they'll not ask you all the steps. You just have to write this number. How you got, it's up to you. If you have any other shortcuts, if you are cutting your time, so do that. Only the thing that you have to write is this answer in the exam. That's very important. Saving your time is very important. All right, moving on to the next one. I have binary to octal. All right, I have this binary number. It's a combination of zeros and ones. Of course, it's correct. Then do I have bases too? Yes. Question is right now. Now, to which conversion I have to do? I have to convert it to octal. Do I have 8 in the base? Yes, I have. And how do I do that? Just reverse the method. That's it. I have this number. Let me just group it to 3333. All right, because we were using the cheat code 421. Okay, so that's why you are just grouping it into 3333. That is one more thing. So why are we grouping it into 333? Why are you taking this code 421? Because what is the range of octal? 0 to 7. What is the maximum number that I have? 7. So do I get, if I perform the addition of 4 to 1, do I get 7? Yes. So within this, will I get all the numbers which I have in the octal? Yes, I have. That's the reason. Alright. So I'm grouping all the numbers into 333. So first group, what I have? 111. 111 in the sense what? 7. How? Because I have 421 code. If I apply 111, so 1 into 1, 1. 2 into 1, 2. So 4 into 1, 4. 4 plus 2 plus 1 is equal to 7. So I got 7. What is the next one I have? So I have 0, 1, 0. So what is that? How do I convert 0, 1, 0? Apply 4 to 1 code. 4 to 1. So 1 into 0, 0. Plus 2 into 1, 2. Plus 4 into 0, 0. So what is the number that I got? 2. Yes, correct. What is the next one I have? 0, 1, 1. I have 0, 1, 1. Apply 4 to 1 code. Alright. So this is ruled out. So 1 into 2, 2. 1 into 1, 1. So you have 3. So I'm writing 3. So the last one I have is 1. So I'll write 1. So what is the answer that I have? 1327 to the base 8. So do I have that in the range? Yes, of course you have. This is how you will convert. This is the shortcut that you should remember. This is the simplest method that I am deriving it for all of you that you need to follow. Alright. So 1, 2, 3. Alright. After that, I have single 1. That's how I have done. This is very simple and easy method. So please utilize this and score good marks in this. Never lose the marks because it's a very simple and easy method. I have decimal to hexadecimal. Alright. So how do I do that? So all of you know that. Okay. If you want to convert from any number like, using decimal, alright, you will be using the division method. So from decimal to hexadecimal. Alright. So hexadecimal you are using. That's why I'm dividing it with a 16. That's why I'm dividing it with a 16. Let's go back and check. Have we done anything like this? Decimal to octal. So we were using 8. Decimal to octal. Please observe here. Decimal to hexadecimal. Since we were using decimal to octal, we were using 8. But now it's hexadecimal. You all know that base of hexadecimal is 16. That's why I'm dividing it with the 16. So division method, all of you will be knowing. So I don't have to explain. But let me explain some important thing, which is very important. Please observe. The remainder here that I will be writing is 2. So 2, all of you know that I can represent that in the hexadecimal number. But when it comes to this, I have the remainder as 13. But I don't have any 13 in the hexadecimal. So instead of writing 13, I will be writing the equivalent of 13, that is D. So you all remember, right? So you all know that A in the sense 10, B in the sense 11, C in the sense 12, D in the sense 13. So it goes on till 15. So that's why I'm writing 13 is equal to D and the next remainder is 4. So what should be my answer? Please, from this side you have to write 2D 4 to the base 16. This is how I convert decimal to hexadecimal. So please don't forget, this is very, very important. Alright, so guys, the next conversion that I have, hexadecimal to decimal. What is that I have? Hexadecimal to decimal. It's a very simple conversion that all of us know. So we have taken ABC. We have taken ABC. So what is the value of ABC? That is what we need to convert first to the numbers. So fine. Obviously, I have to take it from the right side. Okay, right hand side. So what is that I have? So I have C. So what is the value of C? So please understand the value of C is 12. Alright, first I will write that. Then what is the value of B? So 11, I will write that. What is the value of A? I have 10. First I'll write that. Fine. I've written 12, 11, 10. I got it. Then please understand why I have written this. Because I'm converting it from hexadecimal. I'm converting it from hexadecimal. So what is that I will write? 16 to the power of 0, 1 and 2. So then I'll perform the multiplication. Then I'll perform the addition. So this is what all these methods I've already discussed. Okay. So please practice. Only the thing, I don't have to teach you all this multiplication and addition, but you should remember the method. You should remember the method. So have a cheat sheet, create a cheat sheet for all of you. I mean, like, make sure you have the cheat sheet with you, and in that you should write all the conversions and make sure that you will write what is the method that you are going to use to perform that conversion. That's very important at this point of time. So instead of teaching all this, multiplication, addition, all of you know that. But what is that I should remember here, sir, if you ask me? So please create a cheat sheet for yourself and please write what is the method that I have to apply for this conversion. So that's what you have to do now. All right. So guys, the next conversion that I have is binary to hexadecimal. We studied binary to octal, right? Then binary to hexadecimal. We are discussing binary to hexadecimal. So hexadecimal in the sense how much I have 16 numbers, right? Like till 16 I have 0 to 15 in the sense 16 numbers I have. So can I use 421 code? If I perform 421 code, I will be getting only till 7. Then how do I do it? I have to use 8421 code for this. What is the code that I have to use? 8421. If you perform the addition 8 plus 4 plus 2 plus 1, so tell me how much you will get. So 8 plus 4 is 12, 12 plus 2 is 14, 14 plus 1 is 15. So 0 to 15. Do I get all the numbers which I have in the hexadecimal? Yes, I will get. So you have to use that. Alright. So fine. I have the numbers, binary number here. So instead of grouping it in 3, which I was using in the octal, now I have to group it into 4. Please understand this. Please understand this. This is very important. Right. So I am grouping it. So you all know the method. So I have to use 8421. So what is the number that I have? 1011. So how do I do that? 1 into 1 is 1. So 2 into 1 is 2. All right. I'll write plus. So 4 into 0, it's 0. So 8 into 1, it's 8. So guys, how much you got? 11. How much you got? 11. What is the equivalent of 11? So I have to write that. Equivalent of 11 is B. The same way I have again 1011. So 1011 I have already calculated. So it's B. Then again I have 10. Sir, I have 10. I don't have 4 digits. How do I do that? So put the rest of the numbers as 00. Okay. So you have 8421 code. All right. So 1 into 0 is 0. 2 into 1 is 2. So rest everything is 0. So perform the addition. Okay, how much you got? You got 2. So write 2 as it is. So you will write the answer 2bb to the base 16. 2bb to the base 16. This is what you have to do. Okay, this is how you will be performing the conversion. It's very simple and easy. Okay, remember the method. So what is that I should remember? You should remember 8421 code in this method. This is very important. All right. By saying this, I would like to tell thank you to everyone for listening to me. But in return, I request all of you, okay, so to have a cheat sheet with all of you, all right. So please just remember the methods. Remembering the method is very important because all of you know how to perform the division and multiplication. But the only thing is, please remember the method for which conversion, which method are you using. By saying this, I'll sign off. Thank you, everyone. Have a nice day. Bye-bye.